Okay, so what we're going to do is we're going to give a general strategy for finding limits algebraically. Now, before we do that, we have four basic limit laws that are really important for us. And the first one just says that if you're taking the limit of a sum, you can break it up into the sum of the individual limits. The second law says that if you have a constant multiplying a function, you can take that constant out of the limit. That's a really important one. Well, these are all important, but that one we use a lot. And then the limit of a product is the product of the limits, and the limit of a quotient is the quotient of the limits as long as the denominator is not equal to 0. Okay, so now let's write down our general strategy. So we already went over continuity, and we talked about how a function that when its limit exists, if a function is continuous, the limit is equal to the value of the function. So this gives us a general framework. The first thing that we're going to do is, when we're looking for a limit, is we're going to plug it in. So we're going to try plugging in the number. Now, the second thing is that when we plug it in, two different things can happen. You can get a indeterminate form, and so indeterminate form that looks like 0 over 0, infinity minus infinity, infinity over infinity, 1 to the infinity. So there are several indeterminate forms. Now, if this happens, then you do some more work. So you're going to do some algebra. So you're going to maybe factor, maybe rationalize, etc. Okay, now the other thing that can happen, and this one confuses a lot of students, is that you can get a constant over, so when you plug this in, a constant over 0. Now this is different than 0 over 0, and it's not indeterminate. This is different. So if you imagine having a constant, let's just say, for example, 4, and the bottom isn't equal to 0, but it's going towards 0. So like you're thinking about numbers, small numbers like 0.00001. Well, if this is getting closer and closer to 0, so it's going from 0.1 to 0.01 to 0.0. When you divide 4 by these numbers that are getting smaller and smaller and smaller, where is this guy going? The whole thing is blowing up. So it's going to infinity or negative infinity. One of the two. Well, how do you tell which one it's going to? Is it going to infinity or is it going to negative infinity? Well, what you need to do is you're going to plug in a number that's close to it. And what you're going to do is you're going to check the sign. And so once you get a constant over 0, you already know it's going to either infinity or negative infinity. Then all you need to do is check the sign. Okay, so we're going to do a lot of examples. Let me show you an example of what I mean on the second case, because that one is a little bit confusing. Let's say, for example, you're doing the limit as x approaches 3 from the left of 4x over x minus 3. Okay, so here, remember, the first thing from our strategy is you plug it in. So you would plug in the number 3. And so you would get 12 on the top and 0 on the bottom. So then we just talked about this. What this means, since you have a constant over 0, this means that it's going to infinity or negative infinity. Okay, so then the second step is to, in this case, because you already know it's going to infinity or negative infinity, what you're going to do is you're going to plug in a number that's near 3, in this case from the left side. So if you think of a number that's close to 3 from the left side, now you want to get close, you can plug in a number like 2.9. And what you're looking for is not what the number is, but you're looking for what's the sign going to be. Because you already know that it's going to infinity or negative infinity. All you need to check for now is the sign. So if you plug in, let me just write down 4x over x minus 3. Okay, if you plug in 2.9 on top, do you get a positive or a negative number? Well, you're going to get a positive number. If you plug in 2.9 on the bottom, you get 2.9 minus 3. That's going to be a negative number. You don't care what number it is. You just care that it's negative. And so then, if you have a positive number dividing by a negative number, the result is going to be negative. So then you know that it's going to negative infinity. If this would have been positive, then you would have known it's going to positive infinity. But you don't do one. You don't do this one before you do this one. So you always have to check by plugging it in first. Once you know that it's one of these two cases, then you can plug in a number that's close to tell you that it's going to negative infinity in this case.